Hi friends, I am Pritam. In this video, we will see a very important topic. If you are opting for GATE or any other competitive exam such as BARC or ISRO, you will get surely one question from this topic. So do watch this video carefully. In this video, we will see how to find the transfer function or overall gain by block diagram reduction method. So without wasting any time, let us see how we will reduce the block diagrams. First of all, we will see some rules and then we will move to problems. So the first rule is if the blocks are in series. So how to decide the blocks are in series? If the output of one block is connected to the input of the another, then the blocks are in series. Similarly, if the output of G2 is connected to the input of G3, means these two are in series. So if these blocks are in series, then for the overall gain, we need to multiply this. So the overall gain is G1 into G2 into G3. Remember that if the blocks are in series, we need to multiply the individual gains. Now the second rule is if the blocks are in parallel. How to decide the blocks are in parallel? The input side will be connected to one point, the output side will be connected to another point. Then the blocks are in parallel. There may be one more block also. There can be many blocks. So if the blocks are in parallel, we just need to add these things. If we add the individual gains, we will get the overall gain. Here it will be G1 plus G2. If there are two more blocks, then G1 plus G2 plus G3 plus G4. Now the third rule is if the blocks are in feedback loop. If the block are in feedback loop, then the formula is GS by 1 plus GSHS. That positive sign is for negative feedback and the negative sign is for positive feedback. Remember this. Positive sign is for negative feedback and the negative sign is for positive feedback. Now let us see two important terms. Summing point and take-up point. What is summing point? If in a forward path one input is given, then it is called a summing point because we are adding two inputs. And if in a forward path we are taking one input, then it is a take-up point. We are taking the output here. Is whatever the gain until here, we are taking that output. Until here the gain is A into G1. We are taking that output, that's why it is called as take-up point. Now the fourth rule is interchanging the summing points. Let's suppose this is one diagram and this is the another diagram. In this forward path, two inputs are given. Here also two inputs are given. So the output is A plus minus B plus minus C. Here also it is A plus minus C plus minus B. So we can say that these two are equal. Therefore, we can interchange these summing points. But if it is given like this, A minus plus B plus minus C, and here it is A minus plus C plus minus B, then these two are not equal. We cannot interchange these summing points. Let's move on to another rule. Adjusting block gain and take-up points. This is one example. Now, if we want to adjust block gain and take-up points, first of all, we need to find the output. For finding the output, what we need to do? These two are in parallel. So it will be G2 plus G3. It is connected to G1, which is in series, and A is the input given to it. So it will be A into G1 into G2 plus G3 is the output. Here the take-up point is there. So the output of the take-up point is A into G1 into G2 plus G3. If I want to shift this take-up point to here, then what I need to do? Here I have only A. So for this output to be here, we need to multiply it with this term. So if we multiply it with G1 into G2 plus G3, then we will get the required output. So we can shift the take-up point from here to here. In this way, we will move the take-up points. Now let us take one more example. It is given that two take-up points are there, 1 and 2. We want to shift the take-up point 1 to here and take-up point 2 to here. Now what we need to do? We have to find the output here. What is the output here? Here it is A into G1 into 1 by G2, which is A into G1 by G2. But we need the output as A. So what we need to do? if we multiply it with G2 by G1, so it will cancel out. I will get the required output as A. So if I multiply it with G2 by G1, I will get my required output as A. Now shifting the take a point 2 to here. Here the output is A into G1 into G3 by G2. So I want the output as A into G1. If I want the output as A into G1, so I need to multiply as G2 by G3. If I multiply it with G2 by G3, G2 G3 will cancel out, G3 G3 will cancel out, and I will get A G1. So I can shift the take a point 1 to here by multiplying G2 by G1, and I can shift the take a point 2 to here by multiplying G2 by G3. Now let us move on to the next rule, which is adjusting block gain and summing point. Here one summing point is there and I want to shift the summing point to here. If I want to shift the summing point to here, first of all I need to find the output. What is the output here? It is A into G plus minus B. Here also I need the same output. So for that what I need to do? First of all, if I shift the summing point to here, what it will be? A plus B into G. So which will be AG plus minus, it is minus there, plus minus BG. But I need only AG plus minus B. So if I multiply this term with 1 by G, then I will get B. So if I multiply that input term with 1 by G, then it will be, here the output is A plus minus B by G. After that 1G is there. If we multiply it with G, then here the output will be AG plus minus B. I will get my required output. So friends, until here we have learned that there are 6 rules by which we can reduce the blocks. Out of these, 3 are fundamentals and 3 are derived. In the next video we will see some problems. By using these rules we will solve these problems. So friends, if you like this video, do like, comment, share and please subscribe to our channel Amra Backbenchers. Thank you.